Hey everyone, welcome back. Hopefully this will be I don't want to call it the final video, but hopefully this will be the last video for the internet connectivity in and out of the data center as far as routing goes. I've put the WAN routers back in the topology. We're going to start to tackle those next video, and we'll start to incorporate WAN connectivity back to the data center. We'll start to introduce some actual interior gateway routing protocols, which we really haven't even touched on yet. So that's all to come. But today we're going to do exactly what we said at the tail end of the last video, which is since Internet Router 2 has been giving us nothing but trouble with the HSRP, we have taken him out of commission. He is just sitting there at this point. I have been diligently working behind the scenes to try to figure out a fix. I have yet to been able to find a fix for this. Again, I do think it's just that bug, but if I find a fix, you guys will be the first ones to know. So instead of wasting time on that, we pivoted our design to essentially say, okay, we'll have a single router, which we know is potentially a single point of failure from a hardware perspective. But what we can do is we can leverage the second ISP, right, which is coming into Edge 02. What we'll do is we'll trunk that internet over to router 1, just like we did for ISPA. And then once it's on router 1, we'll do our BGP peering, and then we'll touch on some route steering or some traffic engineering as far as BGP goes. Should be able to show you guys how you can prefer one over the other kind of thing. So we're going to tackle all that in this video. So let's jump right in. So we're going to need ISPB. In fact, let me just get rid of all this stuff. We're going to need both edges. We'll leave those. We're going to need INET 01 and we're going to need ISPB. Okay, good. So all the VPCs are up with the exception of 4. That port channel is the one that's going to router 2, so we're not going to worry about that. The only ones we're going to worry about are the ones that are between the switches themselves and router 1 for the moment, okay? So on Edge 02, if we take a peek at interface 1/4, ETH 1/4, we should, because we did this a couple videos ago, we put him in VLAN 802 for the ISPB handoff. So in our data center, we plug our actual fiber internet connection into the edge switch on this port, okay? So this is where it physically plugs in, hence the description handoff, okay? Now we have 101 faces router 1, and that should be in a port channel. So if we look at our port channel summary, we should see that ETH11 is in fact part of port channel 2. Port channel 2 should be nothing more than a trunk, which it is, and if we show interface trunk, we should see VLAN 802 allowed on port channel 2. Okay, so VLAN allowed on trunk, it's allowing everything. Again, we did not prune anything, so in reality, 802 should be able to reach router 1 at this point. However, we have not configured IPs or a sub interface for that matter. Okay, so we're going to follow suit with what we have here. So interface port channel 1.802 encapsulation.1q802. We'll say do show run interface port channel 1.801. So we didn't do descriptions here. We can certainly do that really quick just to keep our sanity. All right. Now, I should have did this last time, but we'll just do 201.222, okay? 201.222. It'll be a /30. All right, and then while we're here, let's just dump the BGP peering in really quick. So we'll jump over to BGP. We'll do neighbor 201.2.2.1 remote AS is 2, right? All right, and then we'll just activate him. And we'll leave it at that for the moment, okay? So now let's go over to ISPB. So now we play the role of the service provider. So gig 1 is the interface going down to the Cisco data center. So we did have the old IP, so we'll modify that. That's fine. No big deal. This was when we were trying to have router 2 in the mix. So we'll say interface gig 1. The description's obviously not correct. Doesn't really matter. IP address is 201.221, okay? /30. And let's just see if we can ping. Okay, so there's no routes, nothing goofy. Okay, awesome. So we can ping that address. Okay, so that means that our access VLAN port here works, the trunk port channel over to router 1 works, and router 1 is now responding since it's on the same subnet. So let's do the BGP on the ISP side. So this is going to be neighbor 201.2.2.2. Remote AS is 101. And we'll go ahead and activate him. We should get a BGP peering come up, which we do. That's a good sign. Let's throw the network statement in. Let's take that responsibility as the ISP and put the network for 201.220 with a mask of /30. This will ensure we don't cause any black holes in our fake internet cloud, if you will. Okay, let's save him. Let's go back to router 1. Now let's see what changes this may or may not have had on our routing. Okay, so first things first, show IP BGP summary. So we can now see we have 2 peers, right? We have ISP-A and we have ISP-B. ISP-B is learning 8 prefixes. ISP is learning 1 prefix, right? And you'll recall that we have that route map on the inbound direction that we were playing with for ISP-A, okay? So these are things to consider as you add multiple exit points to your routers or switches, okay? So if we show IP BGP, so we may have kind of undid, you know, or is undid the right term? Show IP route, let's see. Yeah, so see what happened, right? So we were proficient in our route map filtering when we only had ISP-A, right? We filtered out all of those unwanted routes that we didn't necessarily care about. But now we've added a new peering. We were good stewards. We've got a redundant link now, right? But it just kind of backfired on us in a sense because now we're just relearning all those routes that we've filtered out on ISP-A. So we're going to have to kind of introduce the same filter and attach it to the ISP-B peering, okay? So under BGP, we're going to essentially have to add another statement similar to this for this neighbor, okay? Now, what we can do is we can technically use the same route map, okay? The same route map should work, but the naming is going to be a bit confusing now because this one we called ISP-A, and we're going to attach a route map that says ISP-A in onto a peering that's ISP-B. So it can be a little confusing. So you have 2 options. You either just need to create multiple route maps, or you just change the name to be something generic. right? I kind of like the specific naming because I know that it's geared towards that peer. If you start to use generic names, then it's not as easily identifiable. Again, the common theme that I always harp on about what it's doing, right? You can always check, right? It's not a big deal to check, but I like to be able to go through these configs and just spot stuff and say, oh, okay, I know what that is, or I know what that is. If it's a network that you're continually maintaining or you own, then it just makes your life easier. If you're a consultant or whatever and you're dealing with customer, configs, that could be a different story, okay? So let's just quickly we can mimic what we have for prefix lists and route maps real quick. It's good practice, right? So let's just do IP prefix list, ISP B in, right? So we'll create that prefix list. So now if we do show run section prefix, we should see we have two prefix lists. One's for ISPA, one's for ISPB. All right, so let's do the route maps, or the route map, I should say. So let's mimic what we have here. Permit 5, match IP address. So we're going to take it all the way up to the prefix list, but we're just going to essentially change it to be that, okay? So now we've tied our prefix list to a new route map. All right, so now we have two of everything, right? The only piece that we didn't do is attach it in BGP. That's that statement there. But we have route map B in, which matches the new prefix list, and we have the old route map A, which matches the old A prefix list. So let's go back to BGP, and let's hop down to address family IPv4. We'll grab our neighbor, and we'll attach a route map, but in this case, we're going to attach the B route map. And we can't forget to say which direction we want to apply that. In this case, it's in the inbound direction. So quick verification. All right. So now we have two peerings, right, with a route map on the inbound direction for both. So I'll just speed up the process. I'll clear IP BGP star soft. And hopefully, what I would hope to see here before I hit the enter key is one prefix for, ISPA peering and one prefix for ISPB peering, if we did this correctly. Okay, so that's a good sign. So if we show the IP routing table now, let's see which peer it chose. Okay, so this is the other game that we're going to get into. It didn't flip the outbound, right? So it's still favoring the IP route for ISPA, okay? And there's reasons for that. There's, these BGP attributes. It's a long list of how it kind of determines which route is going to be marked as best and then placed into the routing table. So that's something that you're going to have to familiarize yourself with, because if you start to get into situations where you need to manipulate which route is being used versus which route isn't being used, you have to have a good understanding of the order of operations in which these attributes are used or critiqued, or, that's the determining factor. So, let's check this from the inbound direction as well. Okay, so let's hop over to, let's go to the farthest ISP router we have, which is the loopback one, right? So let's hop on him, and let's check the routing table. So we know that Cisco is advertising the 101.100 subnet, okay? So the loopback router is learning that from 1111. We know that 1111 is ISPA, okay? So ISPA, let's hop on So if we show IP route, excuse me, we have the BGP route for that subnet, right? So in other words, the loopback router is learning it from ISP-A. ISP-A is learning it straight from our router. So it's the most direct path, right? So that kind of makes sense, right? Like, because if it went, well, again, it goes back to the attributes. I can't really speculate. You'd have to go through the attributes to determine why it marked that one as best, or it's favoring that route, okay? So there's a couple things that we can do if we want to manipulate that. So let's talk about how the internet reaches the Cisco data center, okay? So right now, we know that if we trace route to 101.1.0, let's just ping the firewall, or trace route to the firewall. Let me do a no IP domain lookup before I do this. So if we trace route to 101.1.0.5, okay, it's doing exactly what we just verified from the routing tables, but we're seeing it in a trace route form. Router 1, or excuse me, ISP-A down to our Cisco router 1 and then over to our firewall. What if we want it to, maybe the connection that ISP-B is giving us is a larger circuit. It has more throughput, whatever the case may be. Let's just say that we want to favor that ISP on the inbound direction for whatever reason. It could be, it really depends on the customer or the design, but let's just talk about that. How do we manipulate this so that the internet will use a different inbound route to reach us? One of the most easy, popular ways to kind of do it, and it's an older school way of thinking, is to do what's called an AS prepend. So if we come over back to our router, all right, and we show IP BGP, okay, so we're going to go under the routing BGP process. And this is going to be essentially another route map that we're going to play with, okay? So we've already attached an inbound route map, okay? But now we want to attach an outbound route map. The way AS prepend works is our autonomous system number, okay? In fact, this is what I was trying to show you before. Show IP BGP. Yeah. Sorry about that. So Internet ISP-A, when you do a show IP BGP, it shows you the path. And these are the autonomous system numbers, okay? So in order to reach the Cisco subnet, you can see it traverses autonomous system number 101, which is us, right? That's the Cisco ASN. But there's only one of them, okay? There's only essentially one hop through that AS path, if you will. Prepend tells BGP to add hops to the path, okay? So typically what you'll see is we'll take our ASN 101 and we'll say prepend it 3 or 4 times or something like that. So the idea is that when we come back to this router and we look at this, we should hopefully see multiple 101s there. And when the longer the path that you make it, the less desirable it is for BGP. So if we want to basically make ISP be the favored inbound route, we want to prepend A. Okay, so make A a longer path, so when the internet learns about it, it doesn't use it. It uses the shorter path, which is ISP-B. Okay, so that's what we're going to implement on our router. So we're going to say route map, and we got to give it a name, right? So we're prepending A. So I'm going to say ISP-A out route map. Okay, we'll hit the question mark and we'll say set. Okay, so we're not necessarily matching anything. We're going to say set, and we're going to say set AS path prepend, okay? And then it's asking for a autonomous system number. So I'm going to say 101 because that's us, okay? I'm going to hit the space, I'm going to hit the question mark. You can put this in there a couple times. So I'm just going to do it 4 times. I'm just going to choose a random number. I'm going to say 4 times. Okay. So I said set the AS path prepend for 4 101s. Okay. Now, that should be all we need to do as far as the route map goes. So if we do show run section BGP, and we come back over to address family IPv4, again, ISP-A, right? So we're going to go to this neighbor. We're going to say route map, and we're going to grab the name of our route map. And remember, it's important you have to specify the direction. So in this case, we're applying this route map outbound, okay? So we want to tell ISP-A that our path is longer than it really is, okay? So let's clear IP BGP star soft. And before we hop over to the internet routers to kind of check this, we'll give it a second because this advertisement has to propagate from us to each internet router that we have introduced in our topology. So nothing's changed here, right? Like there's nothing really there. But let's do show IP BGP neighbor. We'll say this neighbor, and we'll say what are we advertising him? Okay, so we're still advertising 101. That's awesome. That's what we wanted to make sure that we didn't break our advertisement. Okay, let's just make sure this should have no bearing. But if we looked at 221, okay, nothing's really changed there. Okay, we're essentially, this is something we should probably look at some point. So he's actually learning. He's learning the default route through his peer router, essentially, which is kind of, you got to consider that. Something that you have to really consider when you have routers on site is that you don't want to become an internet transit. That's always been like the joke when you start to play with BGP for your company's perspective is you don't want traffic to come into your router to route out of your router, or if you had 2 routers, it's more common. They say you can become an internet transit, so traffic routes through you, which you don't want to do. It's just going to suck your bandwidth. So that is a consideration that you need to make when you're looking at these types of designs. Anyway, let's go to ISP-A, and let's do a show IP BGP. Okay, so see what changed here, right? So before we had 1, but now we have a total of 5. Because we added 4 with the prepend to the 1 that was already there. All right. So let's see if that had any effect on the loopback. So let's trace route and look at that. So I didn't even check the routing table. I just hit the trace route to just go for the glory. But before we did the prepend, it was going through autonomous system number 1, right? Or ISP-A in our case. Now it's going through AS2 or ISP-B. So we had an influence on the internet's point of view for our routes. All right. So that's an old trick or mechanism. I shouldn't say trick. It's an old mechanism to kind of help steer your inbound traffic the way you want to steer it. Okay. So let's have a quick chat about the opposite direction. What if we want to, first let's check to see how we're routing out. So let's go to, I think it was ISP-A, right? So we've got that route for ISP-A, the default. So if we trace route to 8888, let's do it from the firewall. It's just easier to, I like seeing it from a hop further back. No IP domain lookup, and we'll trace route to 8888. So you can see, right, it's going through ISP-A. So it went to 101.102, which is router 1, or excuse me, router 1 is here. And then it went to 111, which is ISP-A. And then it followed suit up and out to 8888. What if we want to go, again, let's just play the card that ISP is a better circuit, right? So we've already favored it on the inbound direction. Maybe we want to favor it on the outbound direction as well. So one of the first BGP attributes on the list is BGP wait. Wait it's a Cisco proprietary locally significant attribute. So some people don't use it because it's really geared towards Cisco routers. But if you've got a Cisco router that has multiple exit points to the internet, it's a really easy, quick fix to steer your traffic outbound. The most popular one's probably local preference because that's geared towards multi-vendor type environments. Either one will work, okay? So let's go to our internet router. So wait doesn't actually require a route map, okay? So which makes it, I said it was a quick and easy fix because you don't have to worry about doing a route map and all that stuff. So if we show run section BGP, and if we hop down to the address family, so basically the higher the weight, the more desirable the route, okay? So what we want to do is we want to favor ISPB, which is this neighbor, okay? So if we type this neighbor and we hit the question mark, you can see the last option on the list is wait, okay? Set the default weight for routes from this neighbor, okay? So let's type wait and let's see what we can do. So we have a large range of weight to use, so let's just max it at the top value. So let's clear IP BGP star soft. All right. Okay. So now we can take it off and see what happens, but see how the caret is now next to the 2221 or 221 next hop. So that is the best route, okay? So the best route to reach quad 0 is now going through ISPB. So let's check our routing table. Okay, so now we have a BGP route for quad 0, but look at the time. It's been there for 40 seconds, and it's now 221, as opposed to up here, it was in there for, a long time, and it was 111. So we just manipulated not only inbound traffic, but outbound traffic over our, we'll call it, bigger, faster circuit, right? ISPB. Let's just test connectivity. Let's go back to the firewall. Let's trace route to 888 and look at that. So now when we hit the up arrow and we traced, we still went to our our internet router, right? We only have the one router, but last time we used 111, this time we used 221. So we used a different exit point to get out to the internet, okay? So that is two quick ways to kind of manipulate inbound and outbound traffic when it comes to BGP. You can apply that to WAN, you can apply that to internet. Basically, it doesn't matter. It doesn't discriminate against what the connectivity is. As long as it's BGP, you can apply these mechanisms to influence traffic. I always like to say we're playing traffic cop, right? You're allowed this way, you're allowed this way, no, you're not allowed, whatever. Like, that's all we're doing. We're just telling the traffic where it can or can't go, or the preferred way to route the traffic. So I hope, so that kind of wraps up the internet connectivity for the data center, right? So we've built this data center from ground up, right? The next stop we're going to make is getting back to the WAN connectivity as promised. So I stuck the WAN routers back in here because all the trouble that the port channels and stuff have been giving us, I wanted to make sure that we didn't have any issues with that. We are going to configure these things pretty much from scratch next video. We'll incorporate WAN first, and then I had a pretty cool idea to incorporate some, maybe some DMVPN connectivity. So we'll add some internet to the branches so they'll have two exit points. We'll do some IPsec or IPsec VPNs. We'll put DMVPN, which is dynamic multi-point VPN. We'll put all the bells and whistles on. So we'll kind of turn our sites into, I don't want to call it SD-WAN because it's a legacy way of doing it, but it's the same kind of technology under the hood as a lot of these SD-WAN environments use or leverage. So we'll get to all that. It's going to be several videos down the road, but I hope you guys enjoyed this, and I will see you on the next one. Take care.